So good morning, good afternoon, and good evening, depending on where you are. And welcome to this new RECIPT webinar, which is an initiative of the Horizon 2020 Research and Innovation Project, funded by the European Commission. RECIPT is a project aimed to provide relevant and quantitative information on the European risks from global climatic features using a novel scientific storyline concept that maps representative connections between European socio-economic activities and remote climatic hazards. My name is Domenico Bovienzo. I'm a research fellow at the Euro-Mediterranean Center on Climate Change, which is the institution that is hosting this webinar. And I will be the moderator of today's talk entitled Coastal Flooding-Induced Displacement Caused by Tropical Cyclone Idai and the Role of Anthropogenic Climate Change. I would like now to introduce today's two distinguished speakers. The first is Benedikt Mester, who is a PhD candidate at the Potsdam Institute for Climate Impact Research, PIC, in Germany, a research institute addressing crucial scientific questions in the fields of global change, climate impact, and sustainable development. So good morning, Benedikt. And Dr. Bina Desai, who leads program and work, including global monitoring and reporting, and data risk analysis at the Internal Displacement Monitoring Center, which is an international non-governmental organization focused on monitoring and providing information on internally displaced persons. So good morning, Dr. Desai. And I would like now to remind our participants that the webinar is recorded and it will be available on the CMCC event page and on the CMCC YouTube channel. So you will be able to rewatch it whenever you want. Before leaving the floor to our distinguished panelists, I would like to remind our participants that you can post all your questions, comments, suggestions in the box, in the QA facility box at the bottom of your screen, and we'll post them at the end of the webinar, or preferably, if you prefer, like raise your hand and we open your microphone and you will be able to discuss. I would like now to invite Benedikt to take the floor and to tell us more about this interesting topic about displacement in the context of climate change. So I think we can start, and so Benedikt, the floor is yours.
All right, so thank you, Domenico, for this great introduction. You already described briefly, but really good, the outline of the RECIPT project. So what can you expect from today's talk? I'm super glad to be here and present to you our work regarding displacement in the context of climate change. And we are looking today at the tropical cyclone Idai. And what we did is basically, in a nutshell, we followed RECIPT storyline approach and constructed a counterfactual tropical cyclone Idai event. And what that means is we subtracted the effects of climate change and computed an alternative coastal flood event and the corresponding changes in human displacement. And in today's webinar, I will lay out why we did this at all, what were our research questions, and then also how did we accomplish this goal in terms of methodology, models, and data sets. And then I will present to you our key findings and put this into the context of the overall impact attribution and displacement research. And yes, with no further ado, I will jump into the presentation. So here's an overview of my talk today. I will first start off and set the scene and explain to you the importance of displacement. I will talk about the disastrous tropical cyclone Idai event and also what was the role of climate change. I will then go over and explain to you overall the workflow we used. So in terms of model, methods, data set, etc. In the key part, that's the center of our presentation today, I will first start off and looking at Beira city. So this is the very city where TC Idai made landfall, and extensive flooding caused disasters spread all over the city. And we then, in the next step, go from the physical terms in terms of like flood extent and flood depth, and see how this led to changes in displacement following our counterfactual approach. I will also talk about the Informed Severity Index. So this is a tool developed by JRC, and it basically helps us to understand the severity of a humanitarian crisis. And we will look how the severity index changes regarding our counterfactual displacement events. And last but not least, I will give a conclusion and an outlook on the future. Okay, so let's get started. First, I would like to give you a brief definition of displacement. So an internally displaced person, that's someone who got evacuated or left homeless after a natural disaster. He or she fails to return to their home and is neither integrated locally nor into another settlement. And what is important and what separates them from refugees, migrants, and asylum seekers, they stay within their national borders. In the year of 2021, we saw 23.7 million new IDPs. And as you can imagine from this big number, it's really difficult to record IDPs all over the globe. And also, it's difficult to monitor those numbers over the time. So we have here a difference between long-term and short-term displacements. Sometimes the people, they get displaced just for a few weeks and months, and then they can return to their homes. But sometimes they won't get back to their homes never, and they get displaced several times because there are other natural disasters happening, or also there are the combination effects of conflicts. So it's really difficult to monitor the status of a ADP. And luckily, we have one valid source for data on displacement, which is provided by the Internal Displacement Monitoring Center. What you see here, this is the storm track of TC Idai. So TC Idai, it developed as a tropical depression in 2019, and it made landfall for the first time in the central and northern provinces of Mozambique. And as you can see here from the trajectory, it actually looped back to the South Indian Ocean and became first a tropical storm and eventually a tropical cyclone. And then in the 14th of March 2019, it struck again Mozambique near the coastal port city of Beira and caused extreme coastal flooding, but also inland fluvial flooding and also high wind speeds. TC Idai, it is considered to be one of the Southern Hemisphere's most devastating storms on record. It caused damage to housing, infrastructure, and a total of 478,000 IDPs. Here on the left picture in the bottom, you can see extensive flooding in the coastal port city of Beira. And on the right side, this is a picture in the aftermath of the event. People got displaced. As you can see here from the left side, their houses were totally flooded. They could not return, so they were seeking for shelter. And when we look at this TC Idai event, within RECEIPT, we developed 3 research questions we want to answer. The first one is, we would like to find out to what degree has climate change already been affecting the South Indian Ocean? The second question is, how might the coastal flooding by TC Idai might have looked like without climate change? And the third question we like to answer is, how would the number of internal displacements change in a counterfactual world? So I'd like to already answer the first question regarding the climate change role in the South Indian Ocean. What you see here on the left side, this is on the y-axis. It shows you the sea level of the global mean, and over the x-axis, which is the time evolution of the past 140 years. And you see there is a steady increase in sea level, and actually the rate in global mean sea level rise, it's starting to picking up during the last decades. And sea level rise off the coast of Mozambique roughly follows this trend of the global mean sea level rise. What you see here on the right side is annual means of maximum wind speeds over the past 50 years. And you see again, there is a steady increase in the maximum wind speeds, and both higher sea levels as well as more wind speeds, they lead to intensification of tropical cyclones. And that in turn causes more powerful storm surge, which eventually leads to more coastal flooding. So we have here a sound physical understanding that climate change is indeed already affecting the tropical cyclone and the associated flooding in the South Indian Ocean. Now I would like to go over and explain to you how we accomplished to construct these counterfactual Idai events and explain to you what it actually means. So within Received, we use the storyline approach. And with this, you also have this methodology that you have some storyline ingredients. So we first defined a climate hotspot, which is in our case, Mozambique. It's facing an average of 1.5 TCs per year, but it's also affected by other natural hazards such as droughts, but also like locust infestations. And we did not construct any synthetic event, but we used the historic event of Idai. And we also laid out here a clear and distinctive impact transmission pathway. So as I laid out before, we have a sound understanding of the climate change effects already happening today. And as I showed you, this translates into changes in the TC intensity, and that in turn leads to more coastal flooding. And we're interested, how does these changes regarding the coastal flooding translate to changes in displacement? And as Domenico laid out before within Received, we're also interested, what does that mean for EU foreign policy and humanitarian policies? And with counterfactual scenarios, what that means is that we remove the effects of climate change and give our stakeholders an impression of what the event might have looked like. And we're hereby focusing on coastal flooding-induced human displacement. So on this slide, here's the workflow depicted. So if you look here on the left side, we have a factual observed data set. So this originates from observatory data, which was measured during the event. And we can put this data into our coastal flood model and compute a number of factual affected people. And at the same time, we also constructed a counterfactual input data set where we subtracted the effects of climate change and again run our model, but this time with the counterfactual input data. That leads us to a counterfactual affected people. And we also use satellite imagery to account for the fluvial flooding part. Unfortunately, we have no model in our hands right now to reconstruct the fluvial flooding, just observatory data. So we keep this this part of the hazard constant. So we have no counterfactual regarding the fluvial flooding. By then using the displacement data of IDMC, we can compute a counterfactual displacement scenario. And by making the difference between the observed number of displacements and the counterfactual displacements, we can tell how many displacements according to our simulations are due to climate change. I talked about that we have two kinds of flooding. So the first one is the coastal flooding. And we get the results by using our coastal flood model, here depicted on the left side. On the right side, you see the flooding derived from satellite imagery. I will not talk about the two different kinds of hazards and how we actually implemented them within our methodology. So our coastal flood model, to keep this short and simple, it's a numerical wave propagation model named GeoClaw. And we can quantify the coastal flooding resulting from a given storm intensity and the underlying sea level. So as I said before, we have on the one hand, we have a factual scenario. So we estimate the extent and the depth of the coastal flooding resulting from observed wind speeds and present day local sea levels. And then in a next step, we create a set of counterfactual scenarios. So the first scenario, it focuses on lower sea levels. We have here a range from 6 to 17 centimeters. which displays our uncertainty regarding the actual sea level rise in that area. And the second counterfactual, it aims to reduce the TC wind speeds by 13 knots. That's what we observed with our analyses. And it corresponds to a reduction by around about 10%. So when we construct these counterfactual scenarios, we either assume lower sea levels or lower wind speeds or a combination of both. We also performed some sensitivity studies within this work regarding different tide assumptions and also different impact thresholds. Now let's get over to the fluvial flooding part. So as I laid out, we have no model, so we cannot tweak around with the input parameters and construct a counterfactual data set. So what we're going to do is we take a digital elevation model here on the left side, and we also have satellite imagery in terms of flood extent. And if we superimpose both data sets, a colleague of us, Seth Bryant from GFZ in Germany, he estimated the corresponding flood depth. So what we basically now have is also the flood extent and the flood depth for the fluvial flooding part. And in the next step, we combine the coastal flooding and the fluvial flooding together. On this slide, I will lay out our methodology regarding the exposure and vulnerability. So we now have a total flood extent and the corresponding flood depth. And if we overlay this with the population data, we can derive the number of affected people. We assume this displacement happens if people are exposed to flood levels greater or equal than 100 centimeters following past literature values. And we now have the big question, okay, how can we come from counterfactual affected people to counterfactual displacements? And for this, we need a factor, because not every one of your affected people gets eventually displaced. You have to multiply it by a factor, the so-called vulnerability. And we get the vulnerability by constructing the ratio of the observed displacements and the affected people from the factual scenario. And in the next step, if we multiply this vulnerability, which is event specific, and if we multiply it with the affected people of the counterfactual scenario, we can get the number of displacements for each of the counterfactual scenarios. We also, as a side note, tested different effects regarding the water level thresholds, so also 10 or 50 centimeters. And now I will go over to the results, and I will first start off with flooding in Beira city. So what you see here is the red line. It shows you the city districts of Beira city. And the greenish pixels that tell you where a lot of people live, and the more yellow and brown pixel that tell you where rather a few people live. And here are the results for the flooding in Beira and region. What you see here is that most parts of Beira city are actually flooded. And these are the results derived from our model, which was run by the factual observatory data. If we now run the model again, but this time with the counterfactual data sets where we deducted the effects of climate change, we see that there is an observable decrease in flood extent and also changes in flood depth regarding the counterfactual scenario. You see here, if we stick with Beira, that there's like less flood extent, and also some pixels, they change from dark blue, which means there's a higher flood depth, to more light blue or turquoise color. And this is an example how the overall flood situation would change in a world without climate change. And now we want to translate these effects in terms of displacement and for the whole of Mozambique. Here on this graph, what you see on the y-axis is it tells you the number of displacements. And we have here 3 stacked bar plots. And the orange tip of each of the stacked bar plots, it tells you the share of displacements due to coastal flooding caused by climate change. So if we see here on the left bar plot, you see here this number of 0.5. So that means the climate change, according to our model simulations, is responsible for 0.5 of the overall displacements. If we look here in the middle, this is the scenario where we focused on lower wind speeds. We see a value of 3.2, and on the very right bar plot, you see the combined counterfactual effects if we have lower wind speeds in lower sea levels by 3.4%. So if you just look at this percentage number, 3.4% of the human displacement were due to climate change, according to our simulations. That might not seem as a big number, but if you actually translate those percentage numbers into absolute numbers, we see here we have 20,000 human displacements. And this is just for the coastal flooding part. So you have to imagine, in a world without climate change, we would have seen in a catastrophic event 20,000 human displacements less. And as I laid out before, we only constructed here counterfactuals regarding the coastal flooding. So if we also construct counterfactuals for the fluvial flooding, the percentage number would even increase. Additionally, we have a third hazard which might lead to displacements, which are high wind speeds themselves, which lead to destruction and eventually to displacement of people. And what you see here on this plot, you know these two figures in the middle, on the left again already. This is the coastal and the flooding part, and the riverine flooding part, and on the very right side, you see a extreme wind speed field. And we did an additional analysis to test how many people get affected by extreme wind speeds. We used an assumption that inland speeds higher than 96 knots, that corresponds to 50 meters per second, and on the Saffir-Simpson scale, a classification of major hurricanes, this is a really, really high wind speed. So it's a rather conservative approach to assess the number of people affected by high wind speeds. And you see here, this threshold is set by 50 meters per second, and there are just a few pixels on the right side on this plot where we have wind speeds by 51 meters per second. Nonetheless, we have, depending on the scenario, 118,000 up to 360,000 people affected by high wind speeds. And if you would construct a counterfactual world, and we reduce the wind speeds by the 13 knots, which I laid out before, no people would be affected in a counterfactual world. So you see, this might also have a tremendous effect regarding the displacement situation. However, our knowledge is a little bit more limited regarding displacements due to high wind speeds, and we have a more profound knowledge regarding flooding. And now, this is the third and last part of our results. Here, I would like to show you the results regarding the form severity index. So it basically helps you to understand the severity of your hazard of your humanitarian crises. If you look here on the right side, on the very top row, you see that the factual scenario, so that means how Idai happened, it's considered to be within the lower part of the high category of severity. And within Received, our colleagues, they created two additional counterfactual scenarios. One is assuming what if Idai coincide with COVID-19? And the other one is what if a blocked humanitarian access situation would have happened at the same time? So both scenarios will lead to a more severe situation. And you also see this here on the right side regarding the severity index, that it increases slightly. Now, if we look at our counterfactual Idai event, what we created, we see that there is a slight decrease from the high category over to the medium category. So that points out that only with having a counterfactual regarding the coastal flooding, we have already an observable decrease in the severity of the overall event. We can of course, perform different combinations also of the counterfactual Idai event together with COVID-19 or the humanitarian axis, which is blocked, and you see that they counterbalance each other. And on the very bottom, you see if we have all of the three counterfactuals combined, we might still face a higher decrease in the severity. With that, I would now come to the conclusions and the outlook. So from the results I just presented to you, they suggest that climate change may already have substantially influenced the coastal flooding by TC Idai and the corresponding number of human displacements. And also to put our work into context of the overall field of impact attribution. To our knowledge, it's the very first one which looks at displacement. Most studies, they look in changes in damages, and additionally, most of these studies, they focus on high-income countries of the global north, and just a few have a look at low-income countries, such as Mozambique. And when performing these type of impact attribution, it's super important to be transparent and open and explain all the simplifications we made and also the uncertainties regarding our model, the satellite imagery, our assumptions about the sea level rise. So it's a really simplified construction of a alternative TC Idai event. And also, if we look at the storyline approach, by definition, it is a physical self-consistent unfolding of past events. But it is no actual proof that climate change is actually responsible for the 20,000 people that, who got displaced. This is due to, you have the natural variability, and we cannot by 100% like really literally subtract the effects of climate change and be sure that at this very event it played that role. It might be that at this event the role of climate change was rather neglectable, but it might also be the other way around, that it was even more pronounced. But the storyline approach, it helps us to communicate to stakeholders, but also to local communities, and bridging the gap between the climate science with all of the climate scenario analyses regarding SSPs and RCPs, and actually showing them what climate change would mean for a very specific event and how this event would have played out if there was no climate change. If you're interested in more like about the occurrence probability, so what was the likelihood that that change regarding to TC Idai, you would perform a so-called climate attribution study. And also, if you think about it, in a world without climate change, some parameters such as the storm track or the persistence, or the duration of the TC probably might have changed. But we did not touch these parameters, even though, for instance, with the storm track, a few changes in degree of the TC might lead that the TC may have landfall in a totally different area. So that's another caveat in the study. And now to give you an outlook, we also want to integrate our fluvial flooding model in the future, so we can construct also counterfactual regarding the fluvial flooding. And we also want to deepen our knowledge regarding displacements due to high wind speeds. I'm also currently busy with establishing a displacement vulnerability function. So before, we only constructed this event-specific, more on the physical sides focused vulnerability, but we would like also to include socioeconomic drivers which shape the vulnerability, such as economic status, but also what are the demographics in that very area, whatever the social disparities. All of these drivers are important in terms of vulnerability. Another super interesting topic is the cost of displacements. So IDMC found that the average cost per IDP per year was around about $310. But this number really differs from country to country and can go up to $900 per year and per IDP. So of course here also the question pops up, how much of the cost of TC Idai is attributable to climate change? And like if we take these $310 and if you put a price tag on it, you come up with $6.2 million just because of the coastal flooding and the displacement changes due to climate change. But these are really just crude numbers and you count them as an effect, and we have to also put more work into this field. In general, we're also interested in more deepen our knowledge regarding the long-term versus the short-term displacement. And finally, we would like to also apply our impact attribution approach to other extreme tropical cyclone events in the future. And with that, I would like to close. Here are my references, also regarding the photos. If you have got any questions, you can either like post them here in the chat, ask them to me later on. Also, you see my contact details, and in the left bottom, you see climatestorylines.eu. Please go on this website and check out the super interesting work of our colleagues. You will find more storylines, not only on displacement, but also soybean production and other storylines within the RECEIVE project. And yeah, with that, I'd like to thank you, and yeah, looking forward to the discussion.
So thank you very much, Benedikt, for this interesting and entertaining presentation. We can see actually a lot of insights that probably we could discuss later in the QA session. And I would like to remind all the participants so that they can post their questions in the QA box at the bottom of the screen. And so now I would like to give the floor to Bina, our discussant, that might tell us more about this interesting topic. So Bina, the floor is yours.
Thank you very much. Thank you, Domenico, and thank you, Benedikt, for this really excellent presentation. I knew about the work a little bit before, but this has given me even more information. So first of all, congratulations, and I'll come back to that later. I've been invited to just give a little bit of context and a bit of a commentary. And I'll start with the context. At IDMC, you've seen Benedikt and team have been using our numbers. We've been monitoring disaster displacement systematically since 2008. And unfortunately, indeed, every year we report on around 20 million displacements. So these are movements. And this is the one thing that I need to correct you on, Benedikt, that it's not new IDPs. It's not for each event. Indeed, these are usually a group of people, so people on the move. But what we report on are two different figures at the national and then global level. One is the movements, so the instances where people are forced to flee. And then at the end of each year, we report on the number of people still living in displacement that year. And I'll come back to that also. And just the scale that you said, that you shared with us, Benedikt, that last year just 23.7 million displacements in the context of disasters indeed is huge. It's a global phenomenon. And interestingly, also for this work that you're presenting, it's the majority of it, around 94% are weather-related events in which this displacement occurs. Some of which then, have also the potential to be impacted and shaped by climate change already now and in the future. Most of these types of displacements happen in Asia and the Pacific, but more than 10% indeed are reported in sub-Saharan Africa. And it is mainly floods and storms. So really, again, super relevant, the work that you do in that regard, because it's really the vast majority worldwide of displacement in these contexts, but also severe droughts and extreme temperatures increasingly. In addition, in the context of sub-Saharan Africa and also Mozambique, conflict, of course, contributes also to movements and also to the severity of displacement that you just mentioned. Because indeed, it limits humanitarian access in situations where people get displaced by disasters, as well as may increase or worsen the living conditions of people that were already previously displaced. Access to land, of course, is a huge issue as well. So when you think for the future steps about the socioeconomic conditions, I think post-disaster, but also mediated by conflict, the fact that particularly the rural populations, then have limited access to livelihoods is a huge factor when we think about displacement. So for Mozambique itself, maybe just to also flag that, again, coming back to those two different numbers, for last year, we reported only, it's still a lot, but only around 43,000 displacements, so the movements. But at the end of the year, we reported 138,000 people living in displacement, so IDPs in the context of disasters. And that's because Mozambique is one of the few countries actually that has started to monitor and track people in displacement in disasters. That's still rarely the case, and it's something that we hopefully can all collectively advocate for more, because then for some of the research that you mentioned, Benedikt, you would like to move towards next, this basic information is really required, not least also to assess the socioeconomic impacts. And then maybe just two more kind of little context facts, which are also, I think, really relevant when it comes to understanding the impacts and then severity, not beyond the numbers. Is 4 out of 5 people displaced by disasters in Mozambique are estimated to be living in host communities and not in camps or shelters. So again, this is with clear implications for then development and humanitarian support. And also more than 50% are children and young people. So if we think about climate change and also future projections, these are people who are likely to be then affected their whole lives in one way or the other by the displacement they've already experienced, but potentially also future displacement. So all these numbers I just wanted to give, and that information to just really highlight how relevant the work is that you and the team at PIC do. It's really critical to already try and unpack a little bit also beyond these bigger scare scenarios or doomsday scenarios, unpack what is really the role that climate change plays. I think at IDMC, we've been trying to also dispel, in a sense, this notion that climate change will lead to mass migration immediately. And it is mediated through so many different factors, as you already also alluded to. And I think just to highlight, you were very modest in the summing up, I think, of the major achievement that you're making with this type of work. I would like to just highlight them once more. I think one is really for the first time to use attribution science and impact attribution to displacement. So this is something that we really look forward to seeing more of, and we'd be happy to collaborate on. But also, as you said, I mean, most of it focuses, the attribution science is really on asset damage and destruction, and doesn't really then make that link to human impact more directly, and displacement in particular. But also, as you also mentioned, most are in high-income countries, and we do have to, just looking at the numbers, of course, I said disaster displacement is a global phenomenon, but a lot of the impacts, because they're mediated through vulnerability and exposure, are already found, and particularly in relative terms, are already found in lower-income countries. So that's really a major contribution, and the implications that you take it one step further and really look at the implications also for policy and response. You looked at EU policy, but I think from our perspective and working in countries affected by disaster displacement, this is really relevant also and bridges this gap that you mentioned between climate science and policy and planning, also for national governments who are involved in understanding, doing post-mortems of big disaster events, preparing for the next ones, but also preparing proposals to adaptation funds, engaging in policy discussions around loss and damage. This is the kind of evidence that they will need more and more of to be able to really be informed and also go with the required ammunition into those negotiations. And I do see that there's a real demand there. So just really happy to see your future outlook there slide as well, the next steps. I think on all of them, we'd be really keen to collaborate at IDMC, particularly, of course, on the cost estimates, but also really unpacking vulnerability more, because I do think that's the huge next step, is really understanding, having, in a sense, counterfactuals for what if the quality of housing would be better? What if, people's livelihoods were secured? And that's something that we really look forward to working with you and some of the other partners working in this domain. So thanks again for the work, and thanks for inviting us into it.
So thank you very much, Dr. Desai, and thank you for the overview of IDMCC activities and for also the contextualities of the country in analysis. And so now I think we can open the floor for discussion. So I would like to remind all the participants that you can share your questions in the QA box, and or if you prefer, you can also raise your hands and we will mute your microphone so you will be able to speak. I can see that we have already some questions in the box, so we would like to start from that one from Margherita. So do you have any accounts on which groups of the population have been displaced? The society of countries of Mozambique is extremely unequal. Does this come up in terms of who is displaced? I think either you, Benedikt, or Bina, you feel free to answer to it. Thank you.
So maybe Bina, if you want to start off, that's okay for you.
Sure, happy to start off and also maybe cover the next question by doing that. Hi, Mario. Nice to see you online. We don't have usually detailed information on who is being displaced. This is a huge gap that we're also trying to fill, both in terms of age, sex, income levels, but we can derive in some instances and for specific events from where the displacement occurs and from the socioeconomic indicators of a country or a sub-region within a country, what types of groups potentially have been displaced. But this is definitely, and for the case of Mozambique in particular, I could get back to you with more information from our monitoring experts who are monitoring the situations on a day-to-day basis. But it's true that anywhere displacement is usually reflective of the existing inequalities within a society. So that would have come up also for Mozambique. And then just on the cost estimates, very briefly, this is, of course, the key question, how to differentiate from the actual asset damage or from the physical destruction through a disaster. What is the additional cost of displacement? That's the methodology that we've developed at IDMC, which has severe limitations, but is basically derived from an estimation of the providing housing, shelter, and basic services to displaced populations, plus then loss of production and loss of livelihoods. So again, happy to share the information of interest.
Thank you. I'm going now to read the question from Mario. How can these results be linked with an estimation of the overall cost of internal displacement, different to the damage loss estimation on the physical assets? I think, and thank you.
Yeah, I will start first, answering also to Margherita. So I talked about that we're currently also performing some displacement vulnerability analyses. So we were facing also the problem that we have within one event, just limited data regarding the spatial distribution of different people and also the socioeconomic status. So with our new study, what we're currently doing is we look at a set of almost 500 flood events and the corresponding socioeconomic status. So what we here do is we compare different events and we use Weltbank indicators, but also more granular data, which is on a gridded data set, like the demographics or GDP per capita, but also the sex or also the political status of a country. And we compare this by event, per event, and try to find some answers, not within the event, but comparing several events. And we already did indeed found that economic status is not the most relevant parameter. Because you might think of in the very beginning, okay, the richer a country is, then the more resilient, the less likely is that the population get displaced. But according to our preliminary findings, we can show that other factors, such as the degree of urbanization, actually do play a very high relevant role. So this is the way we would like to account for this. And yeah, I think regarding Mario's question, I think Bina already answered this. And then if you allow me, Domenico, I will also like to answer the other questions, like the one from Letizia. I think what she's asking is if we look at the inland flooding part of TC Idai, what are the expects? Okay, yeah. Generally in the climate science, there is this Clausius-Clapeyron relationship, which says that you have with 1% degree in global warming, you also have a higher water evaporation moisture in the atmosphere, which in turn leads to more heavy rain. And we would like to perform also these some sort of counterfactual fluvial flooding analyses for the future. And what I've seen from our analyses that there are some urban centers also in the inland of Mozambique, which were affected by the fluvial flooding. So if we imagine, if we also deduct the effect of climate change, we might also see a effect regarding the fluvial flooding. I cannot give you any numbers, but certainly there is a effect which might be even higher than the coastal flooding. You see before in the satellite imagery, vast parts of Mozambique are covered by inland flooding. So that definitely plays a big role. And then with Lorenzo's question,
so
maybe Bina, you can answer this one.
I'm going to read the question from Lorenzo, that is thank you both the speaker, and is asking for Benedikt, are you already thinking of an approach for looking at long versus short-term displacement? That would also be extremely relevant. Questions on vulnerability and groups facing specific patterns of displacement. Thanks in advance.
We haven't thought about how to include this. What we did here in this study, we looked at how many people get like displaced in general as a sudden impact of the event, and we did not account for how long these people would be displaced. But of course, if we come to the point of assessing the severity of the event and also in cost of displacement, then this question plays a big role. And currently we have not figured out how to answer this. It's strongly dependent on the data available. And if we have information about return flows and that kind of data.
Maybe I can just add to that, because indeed it's in a sense the holy grail of displacement monitoring is duration of displacement. It's a huge gap, what I mentioned earlier, and Mozambique is indeed one of the few countries that has started to look at, to account for people in displacement even after the event. Most countries don't actually, or even organizations don't actually provide that type of information only at the event or a few days later, and then really the data points reduce drastically after that. So it's something that we're working on across the board with partners and countries, always advocating for filling some of those data gaps. And then of course, it's not that easy to estimate, but we do use housing destruction, for example, as a proxy for displacement. So if we can figure out for certain countries or events at least a reconstruction rate that seems reasonable, then you could also look at potential scenarios for displacement and length of displacement. But it's not an easy and clean science.
Okay, thank you. We have also another couple of questions. No, okay, already replied by Benedikt. So probably I would like to ask more curiosity about both Benedikt and Bina, because you were talking about data availability. So probably I was thinking about data from tweets or Facebook or in general big data. How could they implement or improve this kind of analysis? And if you see space for this kind of improvements in this way, in this sense. Thank you.
So data from social media. Actually, we were looking for this event into publicly available data bank which links flood events with tweets from Twitter, and we were looking for validating our flood model using this data, because sometimes people they post a geolocation and at the same time pictures of water levels, and we can then see by comparing our model results of the flood depth with these pictures and the geolocations, how well does our model perform in reconstructing the flood event. So from the physical side of view, this data might be of relevance for our TC-Idai study. Unfortunately, we could not find any relevant data, but in general, that's super important. And regarding displacement, maybe Bina, have you thought about how to incorporate this in your work?
Yes, indeed. And actually, one of my colleagues, I don't know whether webinar attendees can take the floor, and we may not have time now, but feel free to reach out to him, Sylvain Poncer. He's been leading on work that we've done with Facebook, actually, to use, on the one hand, location data of Facebook users to understand better patterns of displacement in and during and after, right after events, but also to understand a bit more on the duration of displacement, like when do people return. Can we open the mic to Sylvain is the question. So if yes, then feel free, Sylvain, to come in. Otherwise, feel free to contact him after the event and he can share the information. There's also, if you Google IDMC Facebook, you'll see a summary blog somewhere, both on the Facebook website as well as ours. But it is definitely a promising approach to try and fill some of the gaps in some events where there is data.
Thank you. I think you addressed this question in general, all the questions in a really good way. So I will leave still a few seconds to any other participants that want to enjoy this discussion, or if Sylvain feels comfortable to open his microphone. And I can see, okay. Welcome, Sylvain.
Yes, good morning, and good morning, everyone. I hope you can hear me, and congratulations to Bina and Benedikt for the excellent presentation today. Yes, regarding Facebook, I wanted just maybe to add that what we have done also with them is to survey the people that have been detected as displaced. It was an important output just to understand the vulnerability of the people behind. I think it's one of the questions that also came during the discussion today. It's who are the people displaced, and having these surveys running with Facebook was very important to understand who they are, how long they have been displaced, when they have been displaced. It was before or during or after the disasters. What really important to know that, and how long they have been displaced. And also through these surveys, we have also the gender perspective there that also allow us to know if the men or the women tend to return earlier to their habitual place of residence. And as Bina said, I really encourage you to have a look on the different publications that we did with them. We have like a box in a publication regarding the survey that we did for Typhoon Hagibis in Japan, and we have like a full publication regarding the Australia bushfire that we did in 2021.
Thank you very much also for this contribution. I can see a last question. I don't know if Benedikt has time to reply to it. If you feel you can reply or not.
I can do this early. So yeah, Letizia asked me, how did you pick the sea level and wind speed values in the counterfactual? You started mentioning it, but if you could elaborate, thanks. So yes, that was one of the more trickier parts, and to explain it a little bit more in detail. So in the region of Mozambique, we really have a lack of gauging on observatory data. So we have no gauge of the coast of Beira, where we can determine the sea level rise over the past decades. So what we used then is we took satellite imagery and numerical simulations, and to show that the rate of sea level rise is really quite follows the global mean sea level rate. And from that, we said, okay, if the rate was similar, then the absolute number of sea level rise is pretty much the same. Then we have a uncertainty from 6 to 17 centimeters. So hereby we account for the uncertainty regarding this value. It actually derives from another study where they dig more into detail and try to elaborate the exact sea level rise in absolute numbers. And regarding the wind speeds, we performed our own analyses. We looked at the South Indian Ocean, and we looked at the annual means of maximum wind speeds. So that means for every year, we looked at the mean of all of the maximum wind speeds, and we saw this mean of all storms. From year to year, it slowly starts to increase, and over the course of the past 50 years, we found an increase by 13 knots. So of course, this is again a really crude assumption, but we took this value and say, okay, in the past 50 years, on average, the storms got by 13 knots. That's corresponding to around about 10% more intense. So this is how we came up with this number. Of course, climate change already was affecting this area before, but we say, okay, this change is neglectable. I hope that answers your question. Otherwise, you can also contact me and I will give you a more detailed answer.
That was beautiful, wonderful. So I think I cannot see any more questions. In case we will collect them and we'll submit to our speakers. I would like now to thank our two distinguished speakers. It was really brilliant, your presentation and your discussion, but also the warm discussion that's followed in this session. And last but not least, I would like to remind you that this video is available on both CMCC YouTube channel and on CMCC event page. And with this, I'm going also to thanks the CMCC and Elena for the technical support and all the other people that organized this webinar. And I can just say thank you to all you, and I wish you a good day. Thank you, and bye. Have a nice day. Bye.
Thank you. Bye-bye.
Bye-bye. Thank you very much.